In part C, says that the diagram above shows a part of the curve of the graph of the function g of x 3 plus 2 sine 1 upon 4x from minus 2 pi to pi to 2 pi. We have to complete the sketch of the graph and explain whether the graph has an inverse. Now to complete the sketch, we'll just substitute values of x into the function. So we'll take values of minus 1 upon 2 pi, pi, minus 3 upon 2 pi and 2 pi. And the values of y we get, we plot them to make a graph. So when we take x equals to minus 1 upon 2 pi and substitute this into the function 3 plus 2 sine, so we'll write it as 3 plus 2 sine of 1 upon 4 multiplied by minus 1 upon 2 pi. Substituting this in the calculator, the value we'll get is 2.617. So 2.617 is over here will be, so this is 3.142 upon 2 and this is 3.142. So this point will be somewhere over here. So this is 3.142 and the value is 2.6. So it will be over here. Substituting x equals to minus pi in this equation, we'll get 3 plus 2 sine of 1 upon 4 into pi. So this will be a negative pi. So substituting this in the calculator, the value will be 2.292. Now 3.142 divided by 2, just to make it clear, this is in decimal, this is 1.571. This value is pi, which is 3.142. So let's say this is 3.142 plus 1.571 divided by 2. This center point is 2.35. So this value will be positive 2.35. So 2.292 will be below 2.35. So this point will be up here. And at negative 1 upon 2 pi, we got 2.6. So it will be a bit above 2.35. When we substitute minus 3 upon 2 pi into the equation, so substituting x equals to minus 3 upon 2 pi, we'll write it as 3 plus 2 sine of 1 upon 4 into minus 3 upon 2 pi. Substituting this in the calculator, the value will be 2.076. So at minus 3 upon 2 pi, it is minus 2.076. So it will be somewhere above 2.292. So it will be just above the line. And substituting x equals to minus 2 pi into the equation, we'll get 3 plus 2 sine of 1 upon 4 into minus 2 pi. So when you substitute this, we will get a value of 2. So at minus 2 pi, the value will be 2. So we'll complete the graph, which will look somewhat like this. Now it also asks whether it is also asking us to explain whether the function g has an inverse. So as we can see that the graph is a one-to-one function, so we'll say yes, as it is a one-to-one function. In part D, it is asking us to describe a sequence of transformations which will combine to transform y equals to sine of x onto the graph of y equals to f of x. So we had y equals to sine of x, and we have to transform it to y equals to f of x, which was 3 plus 2 sine of 1 upon 4x. So as we have to describe three transformations, we'll go step by step. We see that sine of x has become sine of 1 upon 4x. Now this change basically represents a stretch in the in the x direction, and as it is 1 over 4 up here, it means that the scale factor will be equals to 4. So after a stretch in the x direction and a scale factor of 4, y equals to sine of x will become y equals to sine of 1 upon 4x. Now applying a stretch in the y direction of 2 units. So now applying a stretch in the y direction and keeping the scale factor 2, this equation will become y equals to 2 sine of 1 upon 4x. And finally, as it is a plus 3, which means it has moved 3 units in the y direction. So we'll say finally we'll translate. So there will be a translation of So there is no movement in the x direction. We'll just write translation of 0 and 3, and that will be a final answer. Now, if we perform these operations in any different order, we'll not get the same result. So we'll have to give it step by step. In the first step, it will be a stretch in the x direction. In step 2, it will be a stretch in the y direction, and then finally we'll have translation of 0 and 3.